Hi guys, so this is Module 6, Homework 1. We're going to be solving equations by factoring. This is going to help us get caught up so that we will be ready to go and use square root method and quadratic formula in our next class. So we're on page 16, that's where we're starting. And so what you're going to notice about these particular problems is that even though they look like your polynomials that you've been working on, they have one extra piece, and that's that there's an equal sign. So your polynomials will now be equations. That means there's an equal sign in there. If you do not have an equal sign, all you're going to do is factor. That's as far as you can go. If you do have an equation like you do now, you must solve. You have to solve them. And then I want you to pay attention to this little tidbit here, meaning the number of answers that you're going to have equals the largest exponent. So that's going to come in handy in another page or so. So here are the steps. We're going to move all the terms to one side. It has to equal 0 before you start solving. That's important. It also has to equal 0 before you start factoring. Once it equals 0, you want to completely factor the other side. Set each of these parentheses and any GCF letters only, equal to 0, and solve. And then, of course, it would be fantastic if you would check every one of those answers by plugging them back into the original and making sure they're true. So we'll do that a couple times as well. Okay, this that we're doing when we set it equal to 0 and solve is called the zero factor property, just so you kind of have an idea of what we're doing there. All right, so here we go. We're going to try this first one. This first one is super easy because we've already gotten step 1 done. We're equal to 0. Check. We go on to step 2, and look, the other side is already factored into parentheses. So we're good to go there too. We're ready to start step 3, which is that we are going to set each little packet equal to 0. There we did that. And now step 4 is we're going to solve these for x. We're going to end up with 2 numbers, 2 solutions. So when I'm solving for x, I'm just going to get x all by itself. Here I have a -5. Here I'm going to add 4 to both sides. Whoops, I crossed out the wrong thing. Sorry about that. 3x equals 4. And divide by 3. Our second answer is 4/3. So those are our 2 solutions. You can also write some fancy brackets and put both of these in there with commas. You cannot put both of these in parentheses because that would make this x and this y. We don't have a y. So fancy brackets or x equals both, okay? All right, next one. Now we're getting a little more difficult. We still have satisfied step 1. We're equaling 0. But now we need to factor on both sides. We do not have parentheses. So no GCF. I'm going to go ahead and put my A as 1, my B is 9, and my C is 20. Because it's a monic, meaning that A is 1, I can go ahead and do my parentheses, and I can put my letter in the front of each parenthesis. Okay? Now, I need 2 numbers that are going to multiply together to give me AC, which in this case is 20. Those same 2 numbers are going to have to add together to give me 9, because that's B. Okay, so if you go through your list of factors for 20, you're looking at 1 and 20, 2 and 10, 4 and 5. Oh, 4 and 5 will do it, and we can leave them both positive. That'll multiply to give us a positive 20, and they will add to give us a 9. So now I'm just going to place both of these right into the parentheses. I do not have to make these turn into C's and replace my middle term and go through that whole thing where I make 4 terms, because this is a monic. This is a 1. Now, you still could do that and group, and you'll still get the same answer, but it's just not necessary. Okay, so now I'm at step 3. I have them well, I'm at step 2. I have them factored equaling 0. Now I'm going to set each parenthesis equal to 0, and I'm going to solve. Now, most of you do not need to subtract your 4 and subtract your 5. You certainly can, but you're going to know that your answers are -4 and -5, because I'm just going to subtract this 4 right over and subtract this 5 right over. And there we go. Okay, now let's look at these and how we would use these to check our answers, just so that we are confident we know how to do that. Okay, I didn't mean to run off the paper like that with you. Okay, so let's try C equals -4 first. So if I put a -4 back in the original problem here for C, -4 squared is positive 16, right? So here I'm going to check -4. If I put a -4 in here, I get 16. Plus 9 times -4, that's a -36, plus 20. And I want that to equal 0. Add these together, I get 36 minus 36. Sure enough, -4 checks out. Okay, this little hidden answer where I went off the page is -5. Let's check him. If I were to check -5, I put it in here for C squared, I get 25. Plus 9 times -5 is a -45, plus 20 equals 0. This gives me 45 minus 45. That checks out also. So both of those answers are correct. I'm not going to check every single problem, but you certainly could, and that way you're confident that you have the right answer. Okay? All right, so here we are. We're going to start at the top of page 17 with our next problem. Okay, we have z squared plus 7 equals 8z. All right, well, the first situation is this does not equal 0. So I want to subtract my 8z over, and I want to put it in the right order. Remember, I told you not to worry about 4 terms and 2 terms, but 3 terms you have to have in the correct order. So we needed to move that in the right order. Okay, now we're ready to factor. There is no GCF, so I am ready to go ahead and say A is 1, B is -8, and C is 7. Because it's a monic, I can also go ahead and set these little packets out, and they equal 0. My letter is a Z, so I'm going to throw in a Z in the first places of each one. Okay, I need 2 numbers that are going to multiply together to give me 7, because that's AC. The same 2 numbers have to add together to give me -8, because that's B. Now, remember, to multiply to get a positive 7, you can have both positive or both negative. And the only factors for 7 are 1 and 7. So if they are positive, they are not going to add to give me -8. But if they're negative, they will. If they're negative, they will, satisfy both situations. So those are going to be my 2 little magic numbers. And again, because this is a 1, I don't have to put Z's here and replace this. I can just pop it right on into my packet. So -1 and -7. I'm going to set each one of these equal to 0 and solve. Z is going to equal 1. Okay, I went off the page again, I'm sorry. And Z here is going to equal a positive 7. Now, if we look back, we can use that little trick. The largest exponent that I see in my problem is a 2, which means I better have 2 answers when I'm done. And sure enough, I do. Okay, this is an interesting problem here that you have here in the middle. We are equal to 0. Are we factored on the left? Sure, we're all factored. We're all multiplied together. That means factoring. There's no positives or negatives. Okay, so I'm going to now set each factor equal to 0 and solve. Do I need to set the 8 equal to 0 and solve? Let's think about that. I actually do not need to set 8 equal to 0. I get to just ignore him. That's because he's a number and not a letter. Let's think about this for a minute. If I did set 8 equal to 0, do I have a letter to solve? Do I have an x equals? Nope. Does 8 equal 0? No, that doesn't even make sense. It doesn't equal 0. So you get to ignore it. Only if there was an x out here, if it was 8x, then we would set x equal to 0, and that would be one of your answers. Okay, let's keep going. So we're going to add 4 to both sides. We get 3x equals 4. We divide by 3. One of my answers is 4/3. Okay, over here, I'm going to add 7 to both sides. They cancel. 2x equals 7. Divide both by 2. X equals 7/2 is another one of my answers. There we go. Okay, look at this guy. Well, he looks beautiful over here, right? We have, looks like a GCF of x that's been pulled out. There's a factor, but looky here. He's not equal to 0, and that's the problem. So what's going to happen is I have to subtract 2 over to the other side, and then I'm no longer factored. If I subtract 2 over there, I no longer have just multiplication of items over here. So that means I'm going to have to distribute this x. Now I'm going to subtract 2. And now step 1 is done. Now I have equals 0 there for this problem. Okay, I have to refactor this now that I have all my terms sorted out. I do not have a GCF, but I also realize I don't have a monic. This number, which is supposed to be A, is a 5, so I can't just make packets and throw these guys in. I'm going to have to go through those longer steps. So 2 numbers that multiply to give me -10, because that's AC. Same 2 numbers have to add to give me B, which is 9. All right, if you go through your 10s, there's only 2 choices. I want a -10, which means one number has to be positive and one number has to be negative. Well, you're never going to get a 9 out of 2 and 5. So that means these are the 2 numbers. How do I know who's positive and who's negative? I want a 9, a positive 9. So make the bigger number positive. So I'm going to have a -1 and a positive 10. Okay. Now, because this is not a monic, I'm going to have to replace this middle term. So I'm going to throw the letters in the back, and I'm going to rewrite this as 5x squared minus 1x. Oh, good gracious, that scared me. Probably scared all you too. My little holder fell right off there. Okay, well, I don't want to have to start over, so I'm just going to try to get this to work otherwise. Let's see. How about that? That seems to work a little better. Okay, well, that gave me a heart attack. It probably gave you a heart attack. I'm sorry about that. Hopefully this will hold. Okay, so where were we? We were writing this guy over. -2 equals 0. Okay, so we're trying to then group these terms. Now, you could have written them in any order you want. Here I see a GCF of x that I'm going to pull out. That's going to give me 5x minus 1. Write my sign. And here I see a GCF of 2. If I divide out a positive 2, I get 5x minus 1 again. There's my checkpoint. They're both exactly the same. I'm going to pull that one out. That's the same, right? I'm dividing this out. And then in this parenthesis in the back, I'm going to put what's left, which is x plus 2. Okay, now, of course, normally I would be done at this point, but I'm not done because now I have to make each one of these equal 0. So 5x minus 1 is 0, and x plus 2 equals 0. Okay, if we add 1 to both sides, we get 5x equals 1. If I divide both sides by 5, I'm going to get X is 1/5. I know that's written kind of small. I didn't want to run off the paper. This guy here, you can just subtract your 2, and X is -2. And there you go. Okay, and those are your 2 answers. Okay, let's try some more. This page is the most challenging page because look what we have, everybody's favorite. We have fractions on this page. So I know that's kind of an issue for a lot of you. You get scared of those fractions, but here we go. Remember how we deal with these. We just want to get rid of fractions. We don't want our fractions to have the same denominator. We don't want any denominators. And we can do that because we have an equal sign. That's why. So the first thing I'm going to do is look for an LCD. And I'm going to put this 27 over 1 so everyone has a denominator. So if I look at 6, 2, and 1, the smallest number they can all 3 divide into is 6. So I'm going to multiply the tops of every term, even the 0, by that LCD. I'm going to get 6z squared over 6. A lot of you go ahead and realize these cancel. You can just jump right in if you want. I'm going to take it step by step. I get 18z over 2. And then let's see, 6 times 27, I'm going to have to figure that out. That's 162. And this equals 0. 6 times 0 is 0. And I don't need that 1 anymore over there. Okay, if I clean this up, what I'm actually looking at is z squared minus 9z minus 162. And there's my equation, okay? And again, you could have jumped right from here to here. You could have divided these and got z squared. 2 goes into 6 3 times. 3 times 3z is 9z. And then multiplied and jumped right to this step if you wanted to. All right, my largest exponent is a 2. So I need 2 answers when all is said and done. There's no GCF. He is a monic, which is fantastic. I can go ahead and make my packets and throw a Z in the front of each one. I do not have to go through those 4-term grouping steps because he's got a 1 here. All right, A is 1, B is -9, C is -162. All right, goodness. So I need 2 numbers that multiply together to give me -162 because that's A and C. Well, I'll already tell you, I have no idea what those are. I'm not familiar with 162, but we'll get there. They also have to add together to give me -9. Okay, so I'm going to go to my calculator and I'm going to put in 162. Now I know I need a -162. So one number will be positive and one number will be negative. So we'll get there in a minute. So I know 1 times 162 would work. If I divide it by 2, I get an 81. If I divide it by 3, I get a 54. If I divide it by 4, I get a decimal. 5 is a decimal. I can divide it by 6, I get 27. 7 and 8 are both decimals, but 9 gives me 18. Okay. Now remember, one of these will be positive and one of these will be negative, and they have to add to give me 9. Well, I can already tell this is going to be my best bet, right? Down there. And if I want a -9, make your larger number negative. Okay, so you can put these in any order you want, but make your 18 negative and your 9 positive. Okay, now I do not have to put z's here and replace -9z because this is a monic, so I'm just going to throw in the 9 minus 18. Now I'm ready to set each one of these equal to 0 and solve. I'm going to get z equals a -9. We're subtracting 9 to the other side. And I'm going to get z equals positive 18. We're subtracting 18 to the other side. We wanted 2 answers. There they are. Perfect. Okay, let's try another fraction. All right, everyone has a denominator here. So what number can all 3 of these divide right on into? 10. 10 would do it. So every single term is going to get multiplied by 10. okay? We're gonna have 40t squared over 5 equals 10t over 5 plus 30 over 10. I just multiplied my numerators. Now all of these denominators should divide right into there, and I get 8t squared equals 2t plus 3. And again, you could have just reduced this original and hopped right down here if you wanted. Okay, now that our fraction's gone, we need to equal 0. So I'm going to subtract 2t. I'm going to subtract 3. And there's my new little trinomial. Okay, I do not see a GCF. Definitely not a PST. I haven't been looking for those, but he's not a PST. 8 is not a perfect square. 3 is not a perfect square. Okay, so this is also not a monic, so I can't just put my parentheses in there. I'm going to have to go through those steps where I group. So I'm looking for two numbers that multiply together to give me negative 24, because that's A and C. Those same two numbers have to add to give me B, which is negative 2. Okay, so since I'm looking for a negative 24, I know someone's going to have to be positive, someone is going to have to be negative. So if I go through and I factor 24, I have 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Okay, so one will be positive, one will be negative. The only combination to get me a negative 2 is a 4 and a 6. And since I want negative 2, I'm going to make my bigger one negative. So I'm going to have a positive 4 and a negative 6. There we go. Now, my letter is a T, and I want to replace minus 2t. So I throw letters in the back. Okay, let's come up here. I'm going to take 8t squared plus 4t minus 6t, right? Those combine together to take me right back where I started. Minus 3 equals 0. I'm going to group. I see a GCF here of 4t. So I'm going to divide out 4t, and I get 2t plus 1. Don't forget this is a 1. 2 terms there, you better have 2 terms here. I see a minus. I'm going to have to pull out a negative GCF. Well, normally 3 would be my GCF, so I'm going to pull out a negative 3. Watch your signs. It's going to give you a positive 2t plus 1. That's what's going to equal 0. Okay, these are the same. That's great. We'll write it down over here. In parentheses, I'm going to write what's left, which is 4t minus 3. There we go. Now I'm factored. I'm not done. I have to set each one equal to 0. And I'm going to solve. I'm going to subtract 1 from both sides, divide by 2, and I get t equals negative 1/2. Here I'm going to add 3 to both sides. I get 4t equals 3. Divide both sides by 4. I get t equals 3/4. And those are my two answers. All right. Well, we're almost done with this section. Let's flip it over and look at some unusual situations that are going to pop up, okay? These are the situations that you're going to see most of the time. There are also the situations where you really need to keep in mind how many answers you're going to have. When I look at this first equation, this is a mess, and it's kind of strange looking because it's 1 term equals 1 term. I also notice my largest exponent's a 3, which tells me I better have 3 answers when all is said and done. Y equals should be 3 answers. Okay, so I'm going to follow the rules. The rules say this has to equal 0, so I'm going to subtract 25y. There's step 1. Okay, step 2 says I have to factor. Well, my first question when I factor should be, is there a GCF? Sure there is. A y. They have y in common, and y to the 1 is the smallest exponent. So I'm going to pull out a y. I'm going to divide it out. I'm going to get y squared minus 25. There we go. All right, I look inside my packet and I notice these little terms here. This is a difference of squares. I have a difference in two squares. So I'm going to keep my GCF of y, and I'm going to factor this difference of squares with a plus and a minus. Square root of the first term is y. Square root of the second term is 5. Now that I'm completely factored, I'm ready to find my answers. So I know I set this packet equal to 0, this packet equal to 0. What about this y in the front? Does he need to equal 0? Sure he does. Remember, if this were a number, we would ignore it. But this is a letter, and all letters have to equal 0. So out he comes. There's your first answer. Your second answer is going to be a -5. And your third answer is a +5. So sure enough, you had 3 answers just like you predicted. So that's why it's always a good idea to check those exponents. Okay, look at this guy here, solve the equation. All right, I see the largest exponent's a 3. I'm going to be expecting 3 answers. My first step though says I have to have equals 0. Please do not jump in and start factoring. Please follow the steps. The steps said make it equal 0. So I subtracted 2n squared and I added 2. Now I know this is not in descending order. I know it's not. But remember, if it's 4-term or 2-term, you're going to leave the order alone. Do not rearrange it. So I'm going to leave it. I do not see a GCF, and it is 4 terms, so I'm going to group. I see a GCF in this part of n, so I'm going to divide that out. I get n squared minus 1. I have a negative sign. I have to pull out a negative GCF out of the back. I see a GCF of 2, so I'm going to divide out a -2. That's going to give me n squared, watch your signs, minus 1. Okay, there's your checkpoint. They're exactly the same. I'm going to pull that out. That's my GCF, divide it out of each term there, and I'm going to write what's left, which is n minus 2. Okay, normally I'm done, and I set both of those equal to 0 and I move on, but I only have 2 packets, which would give me 2 answers. How many am I supposed to have? 3. What is this packet? He's got a hidden secret in here. He is still a difference of 2 squares. I can keep going. I can put 2 packets with a plus or a minus. Oops, well, I guess one of them should actually be a minus. There we go. Okay, square root of n squared is just n. I'm going to throw that in the front. Square root of 1 is 1. This packet is just fine, so he's just along for the ride. And now I have 3 packets, and I'm going to get 3 answers. So my first answer is going to be a -1. My second answer is going to be a +1. And my third answer is going to be a +2. And there we go. So this was a difference of squares hidden in a grouping problem. So just be aware that that's definitely something that you see quite a bit of. Okay, look at this mess down here. Good gracious. There's a lot of distributing to do, and we're going to have to move everything that's over here on the right to the left. So first thing I'm going to do is distribute. So I'm going to get -7m plus 84 plus m, don't forget the plus m, equals 91 minus 13m. Okay, now I want to move both of these terms over to here. So let me write over these 3 terms. I'm going to subtract 91 and I'm going to add 13m. Okay, look there. That's a lot of terms. Don't panic. Most of these terms can be combined. So -7m plus m plus 13m, I can combine all these together. Negative 7m plus m is negative 6m. Negative 6m plus 13m is 7m. 84 minus 91 minus 7. There we go. Now I'm going to solve this. What's my largest exponent? It's 1. That means I'm only going to have one answer. Okay, if I add 7 to both sides, I get this. I divide by 7, and lo and behold, I get m equals 1. Now, you could have also looked at it from a factoring perspective. This is what you had. I see a GCF of 7. You could have pulled out a 7. You don't have to set 7 equal to 1 here, or equal to 0, so you forget about him. M minus 1 equals 0. M is 1. You would have gotten the same thing. So you could solve it like a linear equation, or you could solve it using factoring, but you will still just get m equals 1 as your final answer. Okay, one more, and then we're going to talk about the Pythagorean Theorem. Okay, here we go. I'm a little blurry. There we go, we fixed it. Okay, up at the top, this is what I see. I see this guy up here, he's not equaling 0. So 8r cubed plus 16r squared, I'm going to subtract 64r because I need this to equal 0. Okay. All right, now I'm going to get ready to factor. I notice I have some GCFs here. My GCF is 8r that I can pull out of there. So I'm going to divide every term by 8r. You can divide 0 by 8r. It's still going to be 0. Okay, I'm going to get r squared plus 2r minus 8 equals 0. Now I'm going to have to factor this little trinomial. I notice he's a monic, which is fantastic. That means I can write my GCF and I can write my factor packets equaling 0. And I don't have to go through the whole 4-term situation. All right, my letters in R, so I'm going to throw R's in the front. Now I'm going to see A is 1, B is 2, C is negative 8. I want two numbers that multiply together to give me negative 8 because that's AC. So one's going to be positive, one's going to be negative. Same two numbers have to add to give me a 2 because that's B. Well, a 4 and a 2 could combine to give you 2. We want a positive 2, and we want one of them positive and negative. So if we want a positive 2, we're going to make the larger one positive and the smaller one negative. And that's what we come up with. We get to pop those right in our little parentheses. We do not have to group because we have a monic. And now we're ready to solve. Now, back here at the beginning, I noticed I had a 3 as my largest exponent, so I should be getting 3 answers. Okay, I don't have to worry about the 8, but I do have to set r equal to 0. That's an answer. This is going to be r equals 2, and this is going to be r equals negative 4. And there we go. Okay. The very last part of this section involves the Pythagorean Theorem. I know it sounds a little scary, but it's not. It's perfectly fine. So this is just a law or a formula made up by a guy named Pythagoras a long time ago in Greece. He happened to notice a pattern when it came to right triangles. Now, a right triangle looks like this. It's just a triangle that has a 90-degree angle in it. It has two legs, A and B, and then across from the 90-degree angle is a diagonal, also called the hypotenuse, that's C. So what he discovered is that no matter the size of the right triangle, if you square the length of these two legs and you add them together, they equal the length of this leg squared. So the Pythagorean theorem is used a lot in real-world applications because it's a great formula to have. So let's read this. An electrician needs to run a cable from the top of a 60-foot tower. Okay, here's my tower, and it's 60 feet tall. He wants to run this cable from the top of the tower to a transmitter box that's located 45 feet away from the base of the tower. So here's the base. 45 feet away is this little transmitter box. And I don't know what to do with it. I'll just call it this weird little thing. There's your transmitter box. Here's your little electrician. Here's his little hat, his little hard hat. Here's his box, okay? He wants to run a cable from the top of the tower down to the box. That's his goal. Well, look here. If the tower's straight, we have a right triangle. And this cable that we're trying to find is our hypotenuse, or our C, okay? So if we take this is leg A and this is leg B, we can use our Pythagorean theorem. So A squared would be 60 squared, plus B squared would be 45 squared, equals C squared. That's our hypotenuse. Okay, 60 squared is 3,600. 45 squared is 2,025. That equals C squared. Add these together, I get 5625 equals C squared. Now, this is not my answer. I don't want C squared, I want C. So, if we take the square root of each side, that's going to give us C. And the square root of 5625, you can put that right in your calculator, it's 75. That's my answer. And you could actually just put feet on there to make it look really nice. But 75 feet would be how long of the cable you need to run. Okay, that takes care of Mod 6, Homework 1. Brings us right on over to Module 6, Homework 2. This is the last section we're going to do on the video. It is just, let's see, 1, 2, 3 pages long. It's very short. There's not a lot to it, but I want to cover it and make sure that you understand what we're doing with it. So we're still solving equations, but this time we're solving radical equations. So equations that have a square root in them, okay? So in order to do that, we're going to use 4 steps. We're going to call them IRSC. How about that? I is going to be isolate. You want that radical term by himself. And I mean really by himself. No coefficients, no adding or subtracting terms with him. He better be all by his lonesome. Okay, number 2, the R is raise. Raise each side of the power of the index, or to the index. Okay, so this is a square root for all 3 of these. That's an index of 2. You're going to want to raise each side to a power of 2. S is for solve. 4 is for check. Not all answers work. Sometimes an even index, like a square root, can cause a problem, so you want to be super careful. Those problems are because sometimes you get extraneous solutions. What in the world is an extraneous solution? It's an extra solution that's not true. So it's a proposed solution that is not a solution of the original equation. And so you don't want that solution. It doesn't actually work. So you have to be careful. Okay, well, let's jump right in. All right, first problem. IRSC, I, we're going to isolate. He's already isolated. He's by himself. 2, raise each side of the power of the index. This is a square root. We're going to raise each side to a power of 2. When you raise a radical to its index, the radical pops off. All that I'm left with over there is 2x. On the right, 2 squared is 4. I'm going to divide by 2, and I get x equals 2. Now, because the index is a 2, I should check myself. If I plug it back in, 2 times 2 is 4, square root of 4 is 2, this checks out. That's how you solve a radical equation. All right, let's go on to the next one. First step is the I, we're isolating. Sure enough, he's all by himself, we're good. He's a square root, so we're going to raise each side to a power of 2. This is going to pop this radical off. I'm left with x minus 11 on the left. 2 squared, I got another 4 on the right. I'm going to add 11 to both sides because I'm solving. And I get x is 15. There's my answer. I'm going to check it since I had a square root. 15 minus 11 is 4. The square root is 2. I'm good to go. Okay, look at this guy. This guy is super strange. This is a little different, huh? Let's think about this for a minute. Can you ever take a square root and get a negative answer? No, you can't. There's no way to do that. Even the square root of a negative number is not a negative answer. This would be 4i, not negative 4. Now, if we had a cubed root of a negative number, we pull the negative out and take the cubed root. That works. But for an even index, it cannot equal a negative number. That is a huge no-no. So just by looking at this, I know the answer is no solution. I can't do it. It's not possible. Now, let's say that you really weren't paying attention and you didn't notice that and you went through with your steps. Okay, let's just pretend we don't know that this is no solution. All right, it's isolated. I'm going to raise it to both sides. I'm going to get 5x equals 625. That's negative 25 squared. Negative 25 times negative 25. Divide both sides by 5. I get x equals 125. Okay, now I go to check it. 5 times 125 is 625. If I take the square root of 625, it is not a negative number. So this is an extraneous solution. Your answer would be no solution. This is your answer, no solution. So if you see an even indexed root, a square root, a fourth root, a sixth root, equaling a negative answer, no solution. You don't even have to do the problem. He's automatically no solution. Okay, let's turn the page here. We have some more. All right, up at the top, here we go. Remember our rules. IRSC, we got to isolate. He is not isolated. I see a minus 3. You have to add 3 to the other side or it's going to mess up your whole answer. My pencil is not wanting to work. There we go. Okay, so now I have the square root of 5x minus 6 equals 3. Now I'm isolated. Now I can raise it. You cannot raise each side if you have a plus or minus. Okay, my index is 2, so I'm going to be squaring. This radical is going to pop right off, and I get 5x minus 6. 3 squared is 9. I'm going to add 6 to both sides. I get 5x equals 15. I'm going to divide by 5, and I get x is 3. I'm going to check it. 5 times 3 is 15. 15 minus 6 is 9. Square root of 9 is 3. 3 minus 3 is 0. That checks out. Okay, oh, looky here, we have a cubed root this time. All right, now he's isolated, so my I is done. I'm ready to raise. I'm not raising him to a 2 this time. I'm raising him to a 3 because he has an index of 3. It's going to pop that radical off. Okay, now I have negative 5 to the third power. So negative 5 times negative 5 times negative 5. It's going to give me negative 125. Divided by 30, I get x is negative 25 over 6. All I could do here really was reduce. What did I do? I divided top and bottom by 5, and that's it. Sometimes you get weird answers like that, and that's okay. If I plug this back in here, if I do 30 times negative 25 over 6, I actually get negative 125. The cubed root of negative 125 is negative 5. So it checks out. All right, we have a lot of isolating to do here. I have all kinds of issues. First of all, I got to get rid of this 4. I'm going to subtract 4 from both sides. There we go. Am I isolated yet? No, look at this minus. I'm not isolated. He has a coefficient of -1 out in front. So I want to divide both sides, or you could multiply both sides by -1. Whatever you want to do, but you want to fix this. This is going to give you the square root of 2x equals a positive 10. Please make sure that you isolate that. Let's move him up here to work on a little bit. Okay, now he's isolated. His index is 2. I'm going to square him. I get a 2x on the left and I get a 100 on the right. Divide both sides by 2 and I get x equals 50. Okay, check him. 2 times 50 is 100. The square root of 100 is 10. 10 times a -1 is -10. Plus 4 equals -6. So he also checks out. All right, last 2. Okay, here we go. All right, look at this guy. This is very strange. This is a root equals a root. This is actually the easiest kind of problem you can have, but it confuses some students because after all, our first step is an I, it's isolate. Well, he is isolated. This root is all by himself on this side. This root is all by himself on this side. You are, in fact, isolated. So they both have the same index. I'm going to raise both sides to a 2. I get x plus 7 equals 2x minus 1. There we go. Look at that. That's beautiful. Now I just have to solve it. Okay, just solve like you normally would. Okay, I'm going to get 7 equals x minus 1. I'm going to add 1 to both sides. Oops. And I get x equals 8, or 8 equals x, however you want to say it. Let's check it out. 8 plus a 7 is a root of 15. Well, that's a little strange. Okay, let's put in the other side. 2 times 8 is 16 minus 1. That's also root of 15. It actually checks out just fine. Even though this is a strange answer, all it has to do is equal each other on each side, and it does. So our answer is x equals 8. I always like to kind of write it over the other way. Doesn't matter. All right, last but not least, look at this guy. We have a 4th root. We haven't had one of those before. Okay, so we have a 4th root. We want to isolate. I see a plus 2 here. We need to move him over. So we have a 4th root equals 2. Okay, now we're ready to raise both sides. What are we going to raise both sides to? A 4 this time because our index is 4. The whole radical is going to pop off and leave us with 5x plus 4. 2 raised to the 4th power, 2 times 2 times 2 times 2, is actually 16. We're ready to solve. We're going to subtract 4 from each side. We get 5x equals 12. Divide both sides by 5. We get x equals 12/5. And there's not anything I can do with that. I know it's ugly, but it is what it is. So let's try it. If I plug it back in, 5 times 12 over 5 is just going to be 12. This denominator and this 5 are going to cancel. I'm going to get 12. 12 plus 4 is 16. The 4th root of 16 is 2. 2 minus 2, sure enough, it checks out and I have a 0. Okay, and so that finishes up what we needed to do to be ready to move on to page 24. Okay, so I hope you learned it all and you understand it. Let me know if you have any questions, and I will see you next class. Bye-bye.